Good morning, everyone. I'm Dr. S. Prathyusha, working as an assistant professor in the Department of Chemistry in VJEC JYOTHI Institute of Engineering and Technology. Before we begin, I just wanted to ask you a question about plastics. So, what do you come to know when you talk about plastic? So, all of us would be saying like plastic is a lightweight material which is very flexible and a good electrical insulator. That is why we know all the electrical wires are coated with the plastic material. But surprisingly, we have the polymers called as conducting polymers. Now let's start with the conducting polymers. By the end of this lecture, you will be knowing about the conducting polymers, their classification, types, and different mechanisms of the conducting polymers, their applications, features, and advantages with limitations. So, the polymers. So, we all know that polymers are light in weight, and we know that they are very good electrical insulators that can be useful in covering the electrical wires to prevent us from electrical shocks, right? So, why those polymers are insulating in nature and how these polymers are conductive today. So, those polymers, their molecular structure and electron orientation are making them to be insulating, but these conducting polymers are becoming conductive. How? That we are going to know first today. So, in this polymers, in the normal polymers, conventional polymers, like if we say polyethylene, polyvinyl chloride, etc., these polymers will have single covalent bonds which are tightly packed and they doesn't have a property of delocalization. So these electrons are fixed and they cannot delocalize. Because of that, they are acting as insulating in nature. Whereas the conducting polymers have alternating pi bonds, single and double bonds, which makes them delocalized, and this property is called as conjugation or delocalization of pi electrons, which make them the polymer to be conductive in nature. So now let's see the different conducting polymers today. So before we begin with the classification and mechanism, let's see the history, how these conducting polymers were invented and by whom. So in 1977, these three scientists, Hideki Shirakawa, Alan McDiarmid, and Alan Heeger, discovered that polyacetylene, after chemical doping, it has exhibited an enormous increase in the electrical conductivity like many other metals. So this groundbreaking work awarded them the Nobel Prize in the year 2000 in the field of chemistry. And this made the scientists to observe the polymers in a different way, and the understanding has completely made it into a different manner. So let's see the types of conducting polymers here and how they are becoming conductive in nature also we'll come to know here itself. So as we already discussed, the conducting polymers are having the alternate single and pi bonds which make the electrons to be delocalized. So how is it becoming conductive? So there are two types, broadly classified into two types. The first one is intrinsic conducting polymer, the other one is extrinsic conducting polymer. Intrinsic conducting polymers are the ones which have this conjugation in their polymer backbone chain, and with those intrinsic with those conjugation or the delocalized electrons, they become conductive. Whereas the extrinsic conducting polymers will be added with some external agent which makes them to be conductive in nature. So this intrinsic conducting polymers are further classified into two types. So the conjugated conducting polymers are the first one. So where we have, like, we can take examples like polyacetylene, polyaniline, polythiophene, etc., whatever having the in the polymer backbone chain, if they have the alternating double bonds, also if any heteroatom is present, then it can lead to this conjugated conducting polymers. So these conjugated conducting polymers will have an ability, like they delocalize the electrons. Moreover, the formation of this conducting and valence band can happen here with the presence of these delocalized electrons, and that Fermi energy gap can be crossed by these electrons when we activate these delocalization process or the conduction process by either giving photolytic energy or thermal energy, so that that activation can make the electrons to go or move to the conduction band, and that makes the polymer to be conductive, and those are called as conjugated conducting polymers. The second type of intrinsic conducting polymers are doped conducting polymers. So these polymers, we can take the same example like polyacetylene, wherein the electrons can move from valence band to conduction band by by adding some external agent, impurity, so that it will lead to a formation of charge, either positive or negative. That is what is called as doping. Doping is a process where you are going to introduce some charge carrier which can make the electrons to move from valence band to conduction band, and this process is called as doping. Whereas doping is of two types, p doping and n doping. So positive doping creates positive charge, a hole, whereas a negative doping, n doping, creates a electron negative charge. So this can be like p doping, by doping with the Lewis acids like ferric chloride and iodine in vapor or iodine in tetrachloromethane, can lead to the formation of a positive charge or a hole creation, which can lead to the formation of a polaron, and further oxidation can lead to like bipolaron and tripolaron, so on. And this can lead to the formation of some positive charge, and that can further make the polymer to be conductive. Whereas the other doping process is N doping. Here Lewis bases like sodium naphthalide can be used to dope the polymer like polyacetylene or polyaniline, etc. And this can lead to a creation of negative charge, an electron, or sodium N-doped polyacetylene can be formed, leaving naphthalene, and that can make the polymer to be conductive in nature. And mostly these intrinsic conducting polymers, they have very good electrical conductivity. They are capable of charge storage, and they can have the ability to exchange the ions. Ion exchange process also it is used, and it is also useful in absorbing the different radiations, which is useful in changing the colors. Because of the oxidation process, it can be used in various electrochromic displays, etc. The other type of conducting polymers are extrinsic conducting polymers. Extrinsic conducting polymers are the ones which are conducting in nature because of the addition of some external agent. External agents can be something like conducting elements like carbon black, graphene, or any other metal oxides, or by mixing the conventional polymer with some conducting polymer is also called as one class of extrinsic conducting polymer. So now let's discuss about the conducting element filled conducting polymers. So we are going to add some external conducting element like carbon black or graphene or some metal oxides or metallic fibers, wherein we can make the polymers to be conductive, and at least a particular percentage, minimum amount of element to be filled to make the polymer conductive is called as percolation threshold, and that depends upon the porosity and surface area of the conductive elements we are adding. So these polyphenol vanillin, polyacetylene, polythiophene, polypyrrole, polyaniline, and polyphenylene sulfide, all of these polymers can be added with some ingredient like carbon black or metal fibers or metal oxides, and we can make them conductive in nature based on their percolation threshold. The other type of extrinsic conducting polymers are blended conducting polymers. So this is the one which we are going to blend the conventional polymer with this conducting polymer, so that the conducting nature can be included into the conventional polymer which is not conductive. So these polymers can improve the physical and chemical properties, also the electrical and mechanical strength of the polymers, conventional polymers. So we can take an example like 40% of polypyrrole, if included into a conventional polymer, it can also give higher impact strength along with the electrical conduction. And these blended polymers are having an important application in electromagnetic shielding. So now let's see the applications of these conducting polymers. These conducting polymers have applications in various sectors, various fields, like medicine field and in electrical field, also in various other sensors, biosensors, etc. So now let's see that flexible electronics and displays. So we can use these conducting polymers in OLED devices, also in flexible LED screens, which can make the, like, as they have the flexible nature in molding process, as they are light in weight, and they can be easily molded into a flexible screen. It is also used in various energy storage devices because of their conductive nature. Also, they can be used in solar cells and in sensors, as they have some gas sensing nature. Different examples like polyaniline and polypyrrole can sense a particular gas, and they are also used in biomedical applications because of their redox reactions and all, and they are also used in antistatic coatings, also EMI shielding, electromagnetic shielding. They can be used as a corrosion inhibitor because of their conductive nature. As already said, the polymers have the as they undergo these redox reactions, they can move from one color to other color, and that is why they can be used even in electrochromic devices. They can be used as actuators and artificial muscles. They are also used in various other devices and even wearable smart sensors. Moving to the advantages, they are lightweight compared to metals, and their conductivity is comparable with metals. Like, they can possess excellent flexibility. Why we are comparing the conducting polymers with metals? In the sense, we all know that metals are the conventional conducting materials, and compared to the metals, these conducting polymers are very light in weight, which make the final product to be more flexible and easily movable, and they can be even having corrosion resistant nature. As metals are corrosive in nature, compared to them, they are they are inhibiting the corrosion. That is why they are more advantageous compared to metals. And electrical conductivity can be controlled through the doping process, and as it is flexible in nature, it can be molded into a thin film or a fiber and coating, and it also has a mechanical flexibility and mechanical strength. Although it has many advantages, still the conducting polymers have few limitations. Like, as polymers, they can lose conductivity when they are exposed to higher moisture or oxygen under a long term period, and they are also still, like, compared to metals, they have a little lesser mechanical strength, and their larger scale production can be a little expensive, and long term environmental stability remains still a challenge. Thank you.